Okay, I'm going to look at a few examples of the hypothesis test for a population proportion. It says a presidential candidate's aide estimates that among all college students, the proportion P who intended to vote in an upcoming election is at least 70%. So at least means greater than or equal to. So my null hypothesis would be P is greater than or equal to 0.70 or 70%. The alternative hypothesis then would that P is less than 0.70. So my alternative hypothesis has just the less than. I'm going to do the left-tailed test then when I do this. Type of statistic going to be the z-test. I'm going to just go ahead and use my graphing calculator. So I'm going to push stat, cursor over to tests, go to 5 for my one proportion z-test. P sub 0 is going to be 70%, so 0.7 or 0.70. X, 145 out of the 235 expressed an intent to vote. So 145 is my X value, 235 is my N value. My proportion, I always use the alternative hypothesis, which in this case is the less than. So the proportion is less than P sub 0, less than 70%. Cursor down to calculate and hit enter. My z-score then is negative 2.76, negative 2.776, negative 2.776. My p-value is 0.003. 0.003. This question doesn't ask for that, but just as a way to compare, because I can find the answer to my question either by using that critical value or doing the p-value. So in this case, they wanted the test statistic. They want the critical value at a 0.01 level. So here we're going to use our ALEKS graphing calculator. Since we're doing a left-tailed test, we have to do negative z sub 0.01. My calculator up, 0.01. And we can see the value of our test statistic is negative 2.326, negative 2.326. So what I'm going to do is slide down to where they have their drawing, because they're looking at the critical region. So when I have my left-tailed test, the null hypothesis is here on the right side. The alternative hypothesis is the critical region right here on the left-hand side. So the value of my test statistic is the negative 2.326. My test statistic was negative 2.776. Negative 2.776 is less than negative 2.326. Since it's less than, that's our alternative hypothesis. So we have to believe that the alternative hypothesis is true, that it is less than. So when we go down to the question, can we reject the claim that the estimate proportion who intended to vote is at least 70%? At least means it was greater than or equal to. We're saying it's less than. So can we reject the claim? Yes, we're going to reject the claim because we're saying it's less than. We're not saying it's greater than or equal to. I'm going to go ahead and also talk about the p-value. The p-value was 0.002. 0.002 is less than 0.10. And if your p-value is less than your alpha value, then you accept the alternative hypothesis, which we said the less than is the one that we're going to accept. I'm going to go to more practice then, and we'll work through one here. A recent study at a local college claimed the proportion P of students who commute more than 15 minutes to school is no more than 15%. So no more means less than or equal to. P then would be less than or equal to 15%, 0.15. That means my whole alternative hypothesis is P is greater than 0.15. This is going to be a right-tailed test then, since we're checking the greater than. My test statistic, again, is going to be a z-test. Again, I'm going to use my graphing calculator. I'm going to hit stat, cursor over to tests, do number 5, This time P sub 0 is 15%, so 0.15. And I'm going to slide back up to my question. It found that 46 commuted out of the 275 sample. So 46 is my X value. My N value is 275. This time my proportion is going to be the greater than. I always use that alternative hypothesis. So greater than P sub 0. I'm going to enter on the greater than, so it's highlighted, and go down to calculate. I find that my Z value is 0.802. My P value 0.211. So Z 0.802, P value 0.211. So the value of my test statistic here, 0.802. My P value, 0.211. So using the p-value method, I'm comparing this to the level of significance. Since 0.211 is greater than 0.05, I have to accept the null hypothesis. So I am going to say that it is less than or equal to 15%. It's not more than 15%. Can we reject the claim that the proportion of students who commute more than 15 minutes is no more than 15%? No, we can't reject that claim because we're accepting the null hypothesis that it is less than or equal to 15%. Now, just for fun, if I were doing the critical value, I'm going to grab my graphing calculator. Since it's a right-tailed test, I do Z sub. My alpha value was 0.05. 0.05, and so if I hit equal here, my critical value would have been 1.64. Since my test value 0.802 is less than my critical value of 1.645, I guess I would round that up to, but my critical value is less than, or my test value is less than my critical value, I would have to go again with the null hypothesis because it's less than or equal to, and the test statistic is less than the critical value. So again, I'd have to accept the null hypothesis that it is not more than 15%. So when the question says, can we reject it? No, we can't reject it. All right, I'm going to go to more practice here and look at one more. A hospital claims that P of full-term babies born in the hospital that weigh more than 7 pounds is 38%. In a random sample of 245 babies born in the hospital, 103 weighed over 7 pounds. Is there enough evidence to reject the hospital's claim at a 0.1 level of significance? So the hospital claims that full-term babies born in their hospital weigh more than 7 pounds. So in this case, the alternative hypothesis is our claim P is greater than 0.38. They're saying they weigh more than 7 pounds, or no, never mind, I'm messing that up. They weigh more than 7 pounds is 38%. So they're saying that it is 38%. That's going to be equal to 38%. Almost screwed that one up. All right, that means our alternative hypothesis is that it's not 38%. They try to trick me with the more than 7 pounds, but we have to say the percentage is 38%. So P does equal 38% is the claim. The alternative hypothesis is it not 38%. So again, I am doing my z-test. I'm going to use my calculator. So on stat tests, go to 5, 0.38 is my p-value, p sub 0. My x value is 103 out of the n value, 245. And this time, our alternative hypothesis is the not equal. So the proportion does not equal 38%. And I'm going to calculate that. And so I see the value of my test statistic is 1.303. Critical value, this is a two-tailed test. Since I'm doing a two-tailed test, I am going to use my calculator here again, and I am going to do, and you can do either plus or minus, but I'm going to do the positive, z sub. Since it's a two-tailed test, I have to take that critical value and divide it by 2. So I'm just going to use 0.01 divided by 2. That gives me my positive critical value, which is 1.645. 1.645. That means that my negative critical value is going to be negative 1.645. Negative 1.645. So if I would draw my curve, my two lines would be at negative 1.645 and positive 1.645. My null is if it falls between those two values. My alternative hypothesis would be the two ends. Is it less than this value or greater than this value? So is it less than negative 1.645 or greater than positive 1.645? Since my test statistic would fall between these two values, it's in the middle, it means we have to accept the null hypothesis that it is equal. So if it says, can we reject the claim that it is 38%? No, we can't reject that claim because we have to accept that it is equal because the test statistic is between these two values. Again, if I look at my p-value, my p-value is 0.192, 0.192. Since 0.192 is greater than 0.1, we would have to accept the null hypothesis. If my p-value is greater than my alpha value, which in this case it is, you accept the null. The null says that it is equal. The equal is the claim. Is it equal to 38%? So when it asks, can we reject the claim? No, we can't. I'm going to do one more. So I'm going to go to more practice again here. The psychologist socializing in marriage counseling claims that among all married couples, the proportion P for whom her communication program can prevent a divorce is at least 76%. So at least means it is greater than or equal to 76%. My claim is it at least that, which means my alternative hypothesis is it less than that. Again, we're going to do the z-test, and I'm going to use the graphing calculator. So I am going to hit stat, go to tests, hit number 5. P sub 0 is going to be my 0.76. And the surveys, 151 of them out of the 215 stayed together. So 151 is my X value, 215 is my N value, and we are doing less than for our alternative hypothesis. So the proportion is less than P sub 0. I got to enter on that so it's highlighted, and I'm going to calculate. My Z value, my test statistic, is negative 1.980, negative 1.980. My p-value, 0.024, 0.024. Got to round that up. And so if I'm checking this with my p-value, I'm comparing it to 0.05, 0.024 would be less than 0.05. If my p-value is less than my critical value, we have to go with the alternative hypothesis. So we're going to say that it is less than 76%. Can we reject the claim that it is at least 76%? Yes, we are going to reject the claim because the claim was, is it greater than or equal to 76%? We found that it is actually less than 76%. Again, if I look at the critical value just for fun, I would take my graphing calculator. Since I'm doing a left-tailed test, since this is a left sen, I have to do negative z, oops, the negative here, negative z sub 0.05, and if I hit equal, my critical value is negative 1.645. So when I'm looking at that, I'm looking at, is my test value greater than or less than my critical value? My test value is negative 1.98, which is less than negative 1.645. Since my critical value, or since my test value is less than my critical value, I'm in the alternative hypothesis region that says, is it less? This value is less than this value. I'm going with my alternative hypothesis and saying it's less than 76%. So can we reject that it's greater than or equal to? Yes, we are going to reject it because we're saying, is it less? So the tricky thing here is to figure out their wording and asking what they're asking. Are they asking for this hypothesis, or are they asking for this hypothesis? Because they don't always ask for the alternative hypothesis. Sometimes they're asking the null, and sometimes does it say, are we going to accept the claim, or sometimes does it say, are we going to reject the claim? So you really have to sit down and think about which one is true, and then what is that bottom question asking? So in this case, it's saying, can we reject that it's at least 76%? Well, we found that it is less than 76%. So yes, we can reject that it is not greater than or equal to 76%. All right, I hope this helps. I'm going to stop my sharing here and my recording.